About exception handling and regular expressions. So let us see what we studied so far. We studied about the data exchange formats, and then before that, we studied about the files and objects. And prior to that, we studied about the functions, and prior to that, we studied about data types, if else conditions, and stuff like that. Okay. So just remember all these examples that we have looked at already. And so let us get started with the exception handling. Okay. So the reason that exception handling exists is because what are first we need to understand what are exceptions. Before that, we need to understand. We will go back to the our basics things. That is how the programs get executed inside the computer, and how RAM plays a role. And then from there we will understand why exceptions concept have come, and what are the problems that it solves. All right. So let me just get into drawing more. So we know that we have the RAM, and RAM has spaces to keep data, and maybe this is our hard disk. This is a hard disk, and this is our CPU. All right. Okay. So when we run the program, so usually when we do not have any problems, that means not the logical problems. So when CPU tries to execute something, it has something called as instruction pointer. So instruction pointer will always point to the next instruction. So it will execute, and then the instruction point will point to the next pointer. So let us consider a case where the next instruction is a wrong instruction. For example, I have an apple, and I have water. Okay. So operations that I can do with this apple and water are limited. Maybe we can take the apple and boil it in the water, but that's a different operation. If I add two apples, that means if I try to add two boxes of apples, if I have seven in one and three in another box, so adding apples will make it 10 apples. But when I try to add apple and water, it doesn't make any sense. So the problem here is we have different data types here. So this is one of the problems. So when the instruction pointer points to the next instruction, and the previous instructions, that is like apple and the water, are sitting here, and it says that okay, there is add operations between these two, and it says that for CPU it's just bits. That means just electrical signals. For at CPU will anyways add this binary numbers. So, but before CPU, we are going to have a control at the compiler level telling that such kind of operations should not be allowed, because CPU is the CPU is very dumb. It does what we say. So at the CPU level, it's only ones and zeros. So CPU will anyways execute that binary operation, that is add or whatever we have given. But in order to avoid this kind of unwanted operations, we tell the compiler itself that okay, if you see compiler or interpreter in the Python's case, if you see such operations, that means say for example there are two different data types, and we are trying to do an operations which doesn't make any sense, so you stop that. So stop the entire execution. So this is one of the example of exception. So for example, there could be there is one more popular exception. Say for example, you are trying to I have number 5, and then inside a loop I'm going to decrement this by 1 every time, and I'm going to divide it by say another counter. Say that counter is currently 3. Okay, so 3 divided 5 divided by 3 is 5, and then every time I decrement this, and I decrement this, so it becomes 4 by 3, and similarly it goes, and somewhere it becomes something like some 2 by 0. Okay, so dividing 2 by 0, it makes a mathematical error. That means you cannot divide a number by 0. So that is a mathematical problem. So this is an arithmetic problem. So we tell the compiler that, okay, do not, if you see this, or the interpreter, if you see this kind of problem, send a exception. So this can handle at interpreter, or even CPU tries to handle this. So this particular error, so this is an arithmetic operation, but usually such things can be categorized as exceptions. So why this exception are problematic is the question. So say for example, I have instruction, say add here, and print here, and multiply here, and some more exceptions here. So not exceptions, some more instructions, multiply, print, add, whatever. Okay, say in our case we try to divide a number by 0 at this level. So this is third instruction, 1 2 3 4 5 6 and things like that. So when I try to calculate that, say I am dividing a number by 0, what happens is, so the Python interpreter says, okay, this is arithmetic error exception, and you cannot do that. The problem is all the statements that are below this statement doesn't get executed. That means the program gets halted. So this is the main problem of exceptions. So this history of this is coming from C, C++. So whenever there is a problem in C, so such problems, such as we are trying to access memory from a memory which is already occupied, or we are trying to access a memory which is occupied by some other process, or we are trying to access a memory which is in a null position, such pointer dereferencing. So such operations cause problem and causes crash in languages like C, C++. So C++ has a exception handling. So similar idea was taken in Java, and Java has exception handling. And how do we exception handling is nothing but, so we saw that in step 3 there was an exception, and 4 5 6 was not executed. So when I do exception handling, we handle this in such a way that, okay, if you see this kind of error, you handle it and then you allow execution of 5 6 and 7. So that means we are allowing program to execute further and handle that problem. So this is the concept of exception handling. And whenever we have already seen some of the exceptions in our during our program execution already. So we will look at them and we'll try to understand what are those exceptions, how is the format of those exceptions. All right. So before that, I want to tell you another concept. That concept is about stacks. Stacks, and then how the while the program gets executed, how the stacks are used. Okay. So when we have when you write a script, that means script is nothing but the instructions get executed one by one. That means one line number 1 2 3 4 and at till the end of the file. Okay, but usually the programs would be written in such a way that there are multiple function calls. So these function calls, in order to match this function call, match in the sense there is an order to call this function call. For example, I have a function called as, let me just change the color. So I have a function called as x. Let me write it here. I have a function called as x, and I have a function called as y. I have a function called as z. Okay, x calls y and y calls z. Okay, so inside x's code there is calling of y, and y calls z. So how do we, in the program, how does any program know that, okay, this is called by this function? So this is handled by something called as stack. Stack is nothing but, okay, when I call x, the the interpreter puts that into a stack, something like this x. Now x has arguments, all and all these things goes into one of the stack frames, and then when y x calls y, so x is has not completed its execution. So y gets called, so y gets pushed into the stack, and then when y calls z, z gets put onto the stack. So why do we need to do this? That is because the x might have more statements after calling y. It is not still in the end. So y might have some statements even after calling z. So this is how we maintain the relationship between what gets called and what is the sequence of the functions. So these functions are put in a stack, and once z finishes its execution, let me just change color. Once z finishes its execution, what happens is we just remove z from this top of the stack. Where is that? Okay, here. Okay. This finishes, that means this has returned something. So the function of z is done. So z gets removed, okay, and it goes out of the stack. So all the variables and all the memory that you have allocated gets released. Then after this, now we have stack pointer at this level. There is a pointer which tells where is the current position of the stack, and then y finishes its job, the it gets out of this one, and then x finishes, and then we have nothing in the stack. So now this sequence is helpful for us to know when the function needs to be executed, and after the function has executed, it returns something. So that return value is passed to the function that is calling, and then sequentially it gets called, and then the return values also get returned. So this is how internally the function calling is implemented in the compilers or in the interpreters. All right. So once we have this, now you might be thinking that why we are studying this. Okay. Now we'll just go back to our code. We'll go to the functions. Where are those? Okay. Here, scope of variable, some function. Okay. If you remember, we had this some function, and then we had some variables and all this. Let us just try to execute it. Let's see if it is okay. So this does something. All right. So don't worry about that. And then let me just try to define another function. Another function called as just another function. Okay. And then I'm going to print some statement, and then I'm going to add some more statements. I'm going to just number it so that we have track of what we are doing. So these are just statements. This could be anything. This could be mathematical operations or if conditions, for loop or whatever. Okay, just for our understanding. So I'm going to call this another f inside some function. Okay, so I'm going to call this another f. So it doesn't take any arguments, and let's just try to execute it. Okay, so if you look at the execution, let me just execute it again so that we can see that. Okay, so this function is called inside some function. Okay, now ours we will look at the stack in a moment, and then this function has executed. Say for example, what I'll do is I'll try to put a statement which throws an exception. say for example I'll put something like print 3 by 0. Okay, let's do what is happening. Now you see that another one is this function gets called sum function. First, we are calling sum function here in below at line number 28, and this sum function is trying to execute line number 8. We have successfully executed line number 8 here. Okay, okay. My variable 30, so this one. Okay. And then it gets a call, function call, another function. We'll get into this function. Now it's calling another one, so this is another statement. So it goes till 2, and you can see that at 24 line we are specifically making it to fail. So this tells that okay, there is a zero division error. This is one of the exceptions. Don't worry about this particular statement yet. So this is how the exception looks like. Now you can see that there is a word called as traceback, and this traceback has tells that where is the what is the problem, and then from in the reverse order it is telling that okay, in the scope of variables demo.py, in this file line number 25 and in this function is called by this function and is called by this function. So let me just get into drawing mode so that it's much clear while visualizing. Okay. So now we have some function. I'll just shortcut it. Some function. This sum function has some statement 1, statement 2, statement 3, and then it calls another function here. So this is big block, and inside this big block there is a small block here. This block is referred to another function. This is another block. This is block of another function. So this function gets called here. So we are moving back here, and it has some statements here, statement 1, 2, 3, and such that. And now we can see that okay, the traceback that you are seeing here, we got an error, and all the statements that were below this stopped executing, and all the statements below that particular statement, that is we are trying to divide this one at 24, all the statements that are below 25 did not get executed, and we simply exited from the process. That means we spawned a process when we started the program. We spawned a process, and the process was executing, and we immediately executed out of the process. That means we stopped the execution of the process. So the reason is we faced the exception. So this is exception that which has stopped all these statements. And the reason that we are calling this as traceback is because this stack, when it process stops in like this, there is something called as stack unwinding. Okay, so what happens when now we had some function, and inside this another function. So this had a problem. So now it's duty of the interpreter, or whoever is executing the program, is running the program inside the RAM. It is its duty to clean up all the resources. So there could be resources already here. So we are just printing it here, but there is no resource involved. So there could be a lot of resources involved in all the stacks. So it's duty to remove all the stack frames and then release all the variables and memory from the stack and free the RAM space to allow other programs to execute. So that is why this you are seeing this traceback. So it stops the execution and then it cleans up the RAM space. So that is why this is called as traceback. That is because this we are trying to trace back from which function this function was called and from which what is the path of this function. So this function was called by some function. So that is what this is executing. This is showing. Okay. So you can see that another function, there is a problem in another function. Okay, now when you're trying to analyze, okay, this is only two functions. In usually when you write a program about say about 1,000 lines or 2,000 lines, you will have about 20-30 functions, and if one fails, you will have a bigger stack trace. But it will be easy for you to understand how that function call has happened. So another function is called by some function, and this some function was called from the beginning. So this is just telling that this is in the module. So if you have 10 functions, there will be 10 such lines like this. Okay, so this is about the concept of exceptions. Okay, so now how do we handle this? So this concept needs to be clear, because it's very easy to teach that okay, there are these kind of exceptions and you handle it like this. But the problem is you won't be able to remember it for a long time unless you always link back our basic studies. That is like there is a RAM and there is someone who is executing the program. So let us get back to that process states here, and let me show what has happened here. Right. The process states in the first class. Right here. So what is happening is, when I started the process got created. So when we try to execute the program, so it starts looking for all the statements that are below that. So it keeps on executing and it keeps on running. So whenever there was a problem, so exception, so it got terminated. So when it is getting terminated here, that is when the operating system or the interpreter in this case tries to clean up all the memory that it was holding. So that, because the main memory here is nothing but the RAM memory, so that if you do not clean that up, what will happen is your task manager here will show that here your task manager. So in Windows it's task manager. In Linux you can use a command called as stop, and then you can see the resources that is getting used. Okay, so if it doesn't clean up, so that's a problem. So for example, in Linux, this is the command similar to what is it called, task manager. Okay, you can see that okay, this task is running and CPU and all these things. So it will never get cleaned up, and you will think that why my program is causing problem and I'm not able to execute any other programs, or even your PC will start get stuck. So in all the programs that people have written, there will be some kind of cleanup. So one of the cleanups that we do in Python is just by stack and void. And in order to handle this, now my end goal is to make sure that the statements another 3, print another 3 and another 4 must be executed. So let us try to handle this. So how do we handle this? Handling is actually simple. So that is quite a simple concept. If you look at the syntax, so once you know this, it's easy to search Google and find out okay, this is what is happening, and you can simply search it, and then you don't have to remember the syntax, and then you find out how to handle that. Okay, so how do we handle this particular problem? So there was a problem while executing, and program halted. So abruptly halted, and from there you need to make sure that it should not get abruptly stopped. At least it should throw some kind of error or print statement saying that okay, there I encountered this error, and then it simply has to move on with the other statements. Okay, so how do we handle this? So there are keywords to handle this. So one of the keywords is called as try. So we tell program that, okay, I suspect this code can go wrong. That means there could be some arithmetic operations. There could be some operations such as I'm trying to open a file which is not existing, or maybe I am trying to open a file which is only open for reading or something like that. So all of these the things result in exceptions. So I try to, while coding as a developer, I think that this code is critical and put that part of code or code block in try block. Okay, so this is the syntax. Just I'll show you the program. This is the syntax. You put inside the try, and then you put what to do when such problem occur in except block. Okay, so we'll just try to use these two statements, and these two statements anyways, you usually don't use these two statements. I It's quite rare, but we'll just learn about these statements. Okay, so we'll just use try and accept. Okay, so let us go back to our program. So this was the problem. So this statement, I suspect as a developer that, okay, this could go wrong, and I put it here, and I put that exception block here, and I'm going to print something related to this block. So I'm going to tell that, okay, there was an attempt to divide a number by 0. So this is my handling of that particular problem. Okay, so I'm going to write this. So now you see that there is no such error that we faced before. Program did not halt abruptly. Now we handled it, and once this exception got generated, or it is seen by the interpreter, we immediately handle that. It is like something like there was a fire incident in your building, and before the building gets crumbled into ashes, so someone looked at that problem, and they called fire engine, or maybe they put off the fire using some fire extinguisher or something like that. So this is how we handled it. Okay, before writing the code, I need to find out what can go wrong and put that into this safety block. This is like our putting things in a lab. So if something explodes, so let it explode inside this, and that explosion I'll handle inside this. All right, so this is like a bomb, like a like, what is that called, grenade. So this is going to explode, so you put some that grenade in a very tight metal box which can contain that, and you contain it and tell that, okay, there was a grenade explosion and I have handled it, telling that, okay, and then let's other statements to get executed. So that grenade should not stop the entire troop to get disabled. So that is the overall idea about exceptions. So this is how we handle it. Now there are many internal concepts of this. For example, when I faced this problem, I know this is a general exception block. I can in fact look at this exception like this and take this exception, and I can even handle specific exceptions. For example, like this. This is a zero division error. Do this, okay. And for anything else, that means there could be now multiple problems. For example, in a troop, there could be a grenade explosion. It is possible that due to heat, some guns might get heated and automatically fire some things. So there could be some automatic firing. So in case that happens, how do you handle that? So for anything else, so there could be multiple things that can go wrong. So here I can something like, I will try to open a file, which does not exist. Say sample file .txt. So this file doesn't exist. Okay, this is another exception. So I am going to get a file descriptor for this. So we saw that how to open a file, and here let me just comment this so that we know what we are doing. Okay. What is happening? Okay, was there a file? Did I save it? Okay. Okay. Now I got an error here. So that was handled. So statements that is below this, that is statement under this, did not get executed, and because the stack pointer jumps from 26 all the way to 29. So now the statements that are below here got executed, but the statement that was below the problematic grenade statement, so this did not get executed. That is because the instruction pointer moves from here directly to exception block. Okay, so now I might suspect that there could be more errors. So this is a static case. So let me just say I'll just remove this and I'll try to execute it. Now you see that I'm trying to I'll put this statement here. I'm trying to open a file which doesn't exist, and there is some other statements here below, and then let me just put another statement in try. So in this particular block, this statement did not get executed. So 27 and 28. So it directly jumped to exception handling here. So it is telling that there is no such file directory. So if you look at the stack frame, so there is another function. Another function was called by some function. So this is the trace back. So, and now I have handled only zero division error. That is why this we still get the execution. So we can handle specific exceptions, or this is a generic exception. So let me just print something. Since I do not know what exactly that particular problem is, so I can handle it generically. Something went wrong. Okay. This is a generic exception. So let us execute it again. Now it got executed. So there was a problem. So after this problem, it was directly the instruction pointer jumped from line number 26 to it looked at a sequence of exceptions. So whether it's a zero division error, no, it was not. It was something related to file. So that was file not found error. So it did not execute this block. It came all the way here. So that is how the exception handling takes place. So it looks at, okay, well, this is a specific exception, and say for example, let me try to open a file which is existing. I'll try to open a file, something like my coins.py.
So we cannot handle two exceptions, is it? Or
We can handle
like one for the file opening separate and then one for the
yes, we can do that.
divisible.
Of course, we can do that. Do it here. Okay, I got what you're saying. Something like like this, right? Yes, you can write it like this.
Okay.
You can
So then it will come inside the try, is it?
correct. So that becomes a separate block of statements. So you can do this. You can do this as well. So
Okay.
yeah. So I was just showing how to. So usually, what we do is you suspect entire function is problematic, and you can put enter function here in the try block. So that is how the sequence of handling happens. So,
Okay.
So now you can see that this is a proper file, and there is no exception, nothing went wrong here. So there was a problem here in line number 29. So there was a zero division error. So that is in line number 29. It came here, and it handled that exception, and it moved on to line number 37 and 38. So that is how the exception handling takes place in the Python zone. Okay, so that is about it. So in C, especially because in C plus plus we have this similar keywords. In C, usually what happens is how difficult it is to analyze stack trace, because the concept is same thing. In C also there is a there are function calls, and inside the RAM we populate one function on top of another function, and then we unwind the stack. Whenever there is a crash, problem with C is we do the memory handling manually. That means we write code in order to allocate and deallocate the memory. You might have seen that malloc and calloc, and then we do free of those pointers. So whenever there is a problem, we need to write code to deallocate those memories, or else it will lead in something called as memory leak. And then in order to analyze this particular stack of functions, in C we do something called as we add a flag while compiling, and we do stack analysis, and there is something called as core dump, and from that core dump we try to analyze what went wrong. So that's a difficult job. If you have done that, you see that in Python it's very quite simple. There is no memory problem, and there is no core dump, and analyzing core dump file will take actually it can take weeks to analyze them, because in bigger projects there are a lot of function calls, and you won't know what caused the problem. Okay, so that is about the problem, and how Python is quite simple in handling such problems. Okay, that is about exceptions. So the syntax is like this. So now we used try and except. You can also use the else. So if there is no exception, run this code. Actually, this is actually, I think this is a redundant statement, because anyways the statements that are following try exception block, it gets executed. But if you want to specifically do something, you can add else block. And finally is like even whether exception has occurred or not, regardless of that, that finally code will get executed. Usually in this finally code, you could be doing something like memory cleanup, or you could be writing some logs, or you could be deinitializing something. That means you might have initialized something in the try block, and regardless of whether there is an exception or not, this finally block gets executed, so that you have a clean way of handling statements. Okay. So but these two statements are important. Usually you see these two statements, put anything that is suspicious inside the try block and handle that inside the exception block. You can do specific handling like this, or you can do generic handling like this. So if when you do specific handling like this, the advantage is that the lookup for the compiler, we are helping the compiler, telling that you don't go through all the list of exceptions that you have. You just try to match this exception. That means we are actually giving him a key that okay, handle only this error. So that helps us to reduce the speed of the program. That means if it takes 2 seconds, if I do specific handling, it might take maybe 1 second or lesser than that. So but if you do not worry about the time, so you can just do the generic exception as well. Okay. And one more advantage is you can write your own specific code for those specific exceptions. So that is about specific exceptions and except block. So this is quite simple, but you must always imagine there is a RAM and there is a stack trace, and that is how the exception has come, and that is why you see this kind of stack trace that we saw here. So if you look at this, you must the idea that image that you must see in your head is there is a stack in the RAM, and stack unwinding has happened. So once you have this, you will be even if you see in another language, it is now the concept is clear and you know that okay, this is how it is handled. Okay, so that is about exceptions. Any questions? No, we'll just briefly look at regular expressions. Okay. If there are any no questions, we'll jump into regular expressions. Okay. Okay. Let me just get into drawing more so that we can start the concept. Okay. Okay. Before starting actual regular expressions, so I'd like to give some examples that we see in our daily life. For example, whenever as humans, whenever we see objects, we easily recognize that. For example, when you see a tree, tree is something like this, and it has a branch and branches, and then there are leaves and things like that. Okay, under this there could be roots and something like this. So whenever we see this structure, even if I don't tell, so we see this picture and say that okay, this is a tree. All right. So and anything that you see, for example, if I draw something like um, something like this, you see this is a rectangle, and if I draw something like this maybe imagine this as a sofa or bed or whatever. Okay, so things like that. So whenever we see some things, we recognize it immediately. So how are we recognizing it? So idea is, so whenever from our young age, we try to if you look at your kids or your kids around you, so what they do is they try to recognize an object and try to imagine that okay, this is a this is a phone, this is a pen, and this is a mobile phone and things like that. So if you have small kids, you might be seeing that they will pick up some boxes, small boxes, and keep it on their ears and then say hello and things like that. They think that it's a phone. So what is happening in their minds, or what is happening as human is they're trying to recognize objects, and then they're trying to learn what it is from the information that they have got. So now they do not know how a phone works internally as we adults do. So we know that there is a signal and there is we need to charge it and things like that. So they don't know that. So whatever the minimum information that they have got is that okay, it looks like a box, a small box. So people or parents keep it on their ears and then they keep on talking on it. Okay, so that's all they know. From that information they try to recognize an object. So now let us get into one more next step. So if you say for example, if you are say fifth standard or sixth standard, what happens is if I show you something like this this particular number, you'll see that okay, this could be a section number, or this could be some chapter, 10th chapter, 10th section, or something like that, or this could be a question number. And then if you show the same number to someone who is working in IT industry, he will immediately tell that okay, this is an IP address. Okay, so there are common patterns from where we recognize things and we make assumptions based on the patterns that it looks. For example, if you show this pattern to a 2-year-old kid, maybe no, not 2 years, second standard kid, maybe he or she will recognize this as simple numbers. He or she will recognize it as 2 2, and there is 0 7, and there is 2 0 2 0. But if you show to a fifth standard kid, he will immediately recognize that this as a date. So this particular information, how we interpret, is based on the context. So whenever we look at text, because we humans are um, largely communicating on text basis whenever it comes to knowledge transfer. For example, you're reading blogs, you're looking at files, and you're writing code and all these things. So this has emerged from common languages. For example, we are using English, and that text is being parsed and understood all the time that we are looking at anything. So if you look at while going in the bus, if you look at stop shops, you try to read those the shop names and things like that. So all these patterns are getting into our head, and we are making patterns. Similarly, computers does not know. It doesn't matter how long you are using the computer for. 20 years, the same computers, it cannot recognize what is the pattern of this. That is because it doesn't know how to learn. So this is where the machine learning has come, and it tries to recognize the patterns, and it classifies that okay, this could be IP address, this could be a number. So it classifies it as a some set of numbers, and then again it classifies, maybe it classifies it as an IP address and things like that. So that is where the machine learning space has come. So why do we need to know all these things? Because the regular expressions are very specific to a particular context. So for example, if you have a list of say phone calls, so you have a list of phone calls that went from your phone. So if you want to check out what whom all did I call between in the last week, so in the last 7 days, so you will try to filter out the data from your entire call log into this particular set. So how do you extract? As humans, we just scroll and find out, that is okay. But when you write a program, you need to specifically tell that match from this particular date to this date. So we are trying to filter from the computer point of view, and computer needs to know where to start and where to end, what to look for. These searches can be done using regular expressions. Okay, so let us get into regular expressions. So we know that okay, this is a IP address. So some common examples, for example, you could be just now I told about the phone and call log, and you could be analyzing some logs that you have got from customer or a development team or a testing team or wherever. So you get logs something like this. A log has date, and it has some text inside that. If you want to find out, say for example, there was the connection loss, there was a connection loss in between 31st October and 1st November, in those 2 days, October, November, yeah, in those 2 days. So how do you, so you don't need all the logs before that and below that. So how do you extract? You write some kind of program telling that okay, extract this. So that is one of the examples. Now the text contains what does text contain? It can contain let me just get into drawing mode once more. It can contain alphabets, it can contain numbers, it can contain special characters, it can contain spaces, invisible spaces. So it can contain tabs, it can contain new lines. We saw what are new lines, and things like that. So these are the common things. So if you look at this particular line, so this is a number, this is a number, this dot is which is not alphabet as well as it is not a number. So this can be like a special character. So this is another special character. Now this is a number, this is a text again, things like that. So now let us try to extract. If I want to extract this particular line, so this line says okay, from this IP address this command was sent, and there was some code. Okay, so in order to extract all the IP addresses, say for example, let us just take one example, scope of variables. So regular expressions are nothing but we are trying to write expressions. It's like a simple mathematical expressions in order to extract text data. Okay, so there is a library called as RE. RE stands for regular expression. So let me just give some example. String s x is equal to 3.5. This is not a valid IP address. Let me try to give this address. Something went wrong on 23rd August 2020. Okay, something like this. Okay, this is the string. So let us just take one piece of string and try to find out what is the IP address. So for example, in this case, we since we are writing it, we know the IP address. Say imagine that you are getting logs from all the network, so you don't need to know the exact IP address. So but you need to find out all the logs which contain an IP address pattern. So let us try to make a pattern. Okay, I'll first try to write a pattern and then explain what is it. Rejects IP. Dot, dot. Actually, regular expression is quite a vast subject, so I'll just give you a glimpse and it, because we can learn about all the regular expressions, but we won't be able to remember it because there are too many expressions. Okay, so I'll just put this re dot I think it is find all. So now I'm not remembering anything, so what I'll do is I just took a chance and it says that okay, this is a type error, find all missing two arguments. It takes a pattern and string. So let me try to give it a pattern. Pattern is nothing but regex IP. This is the pattern that I'm looking for. So I don't need to know the exact IP address. I just want all the lines containing IP addresses. There could be a lot of logs which doesn't have IP addresses. I'm just in the first level. I'll just filter that. Filter for lines containing IP addresses. Okay. So that is this one. Fine. So what is happening is in this line. And let me add for clarity. Let me add a new line here. Some line. So there is a new line, some line 2 and one more line. Okay, so if I put S, so this is a string which contains new lines. Okay, so if you just try to print this, actually this is a single string, but it is separated by new lines. New lines means it's like having a enter key inside that. So there are multiple lines. So what I need to do is I just want a line which is containing or text which is containing this IP, some IP address. I do not know its exact IP address, so I have written an expression saying /d/d. We'll look at all the expressions, but without even knowing the IP address, I am trying to extract it. Okay, so let me try to extract. I can even say, instead of this regular expressions, I can even say something like /d. I will try to extract this particular thing. So I do not know the date, but I want all the lines containing dates. So I'll just do, there are many functions. So this is the pattern. So instead of that, in August. So now I found a line which is in 23rd August. If I change, even if I change this line into 30th August, it doesn't matter because I'm finding a pattern. Okay, so there are multiple functions. This is just to find extract all the entries. You can even search. So it tells that okay, this is matched in between these things. So there are multiple functions. We'll just look at those functions in just a brief. So the idea is we are trying to extract some pattern from a text file. So what are the patterns here? So I have used /d. So /d means find a digit in given text. So capital D means find text which doesn't contain digits. So usually just focus on small letters. Slash D means find the digit. Slash S means find white space characters. White space characters could be tab, new lines, written carriages, and this is vertical spacing, and I think F is end of the file or something like that. So there are several expressions. So these are called expressions. So this slash D is their expression. So why do we need to use slash? That is because if you simply write D, say for example I'm going to simply write D, it tells that okay, I'm not finding anything. That is because it is trying to search for the string D plus. So I don't want to search for D plus, I want to search for a digit. That is when I escape D, telling compiler that do not consider D as a normal character, consider it as a special character. That special character goes in as a mathematical expression, and we are trying to extract the digit. Now it considers that as a special character. D is not just a normal string. Now it thinks that okay, I am searching for a digit, and it gives the digit. So that is how the regular expressions have emerged. So there's you use spaces, and in fact you can also find out this plus means repetitive digits. That means if I have two digits here, even if it has 1,000 or 10,000 or any number of digits, it will match those all the digits. So if I simply do just D, here it matches only for one digit. So it's quite vast, this regular expressions, but unless you use it, it's not worth to tell you all the ways and internal working of regular expressions. But you must know that what we are trying to do, we are trying to match some common patterns out of extract or find. In fact, you can replace. For example, you want to replace in one of the projects I was working. It was something like we get all the logs so all over from the place. Our job was to make sure that these IP addresses get replaced by dummy IP addresses. That is because these logs would be sent to various other people, and they should not get to know about our IP addresses because they can use it against it, and they might hack our systems. So in order to do that, what you can do is you can write in a regular expression to find out all the IP addresses and replace it. So you can in fact replace it as well. So this is the documentation of regular expressions. You can read through this. There are several interesting things, but reading is good, but unless you do it, you won't know its particular use. So that is a very simple regular expression, brief introduction to regular expressions.
Sir,
Yeah.
sir, actually, what is re dot find all and re dot search?
Okay, these are just
Actually,
functions. In another class we studied, right? So everything is an object in Python. So that you know, right? So when you do import RE, so this is a module which is written by some other people. RE is a library. RE is a library. RE stands for regular expression. So if you look at this type of RE, it tells that this is a module. So how do you look inside the module? We learned that when you had a car, object object known as car. How do you look inside the car, looking for its parts and operations using a function called as dir. If you look
yeah.
inside this dir, so there are lot of functions. So find all is one of the functions which gives. Let us see what it gives. Let us just repeat the concept here. Find all. Okay, how to see the documentation inside that, like this, because someone must have written a doc string. Doc string is nothing but the scope of variables. Where is that? We looked at function. Doc string is nothing but something like this. This is the doc string.
Yeah.
Okay. Some whenever developer who has written this particular function, he must have written a doc string. Okay, that is a good practice. So usually all the professionals write that. So if you look at that, this function returns a list of all non-overlapping matches inside the string if one or more capturing groups are present in the pattern. it lists of the group. This will be a list of tuples and patterns. So you can read about this. So this is how. So you have a module. So similarly, you have search. So there are several functions. In fact, you can compile the regular expression into a object and you can use it. So one of the functions was search. Where is that? Here. Yeah, this is one of the functions. Search does just the search, and it gives in a certain format. So it gives an object which matches. Find all returns a list. So if you have multiple IP addresses here, it will just return all the IP addresses. So find all is like extracting the data. Search is like just searching the data. It tells whether it is there or not.
Okay, okay.
Okay.
Got it.
Okay. So that is about regular expressions. You can, in fact, you don't have to remember anything. So you need to understand the use case. For example, in your project, you could be raising, say, if you have an automation system where you have Jenkins running, and you have a Python script which will automatically look into the logs that is generated and tells that what could be the problem. So if you write this function, you need to know what you are looking for, and then you need to search the internet. For example, that could be a complicated regular expression. For example, find out IPv6 and IPv4 IP addresses in the logs. So if you start writing your own regular expressions, you will be lost, because you need to understand first thing, what is an IP address made up of, what is IPv6 made up of, and then you need to understand what are those. For example, 366.1.1.1 is not an IP address, but if you start writing regular expression, you could be going wrong just by matching these things. So search those regular expressions and put it. The only thing that you need to understand is how it works internally. So that is what we are more worried about. So we learn about how it works internally, and then we try to implement it. So for smaller regular expressions, as we did, so this is very simple. So we just did the string matching. But for complicated, always search internet and extract those regular expressions. I'll just show you some regular expressions for IPv6 and regex for IPv6. You will see how complicated regular expressions can get. But you don't have to remember all these things. See, this is the regular expressions for IPv6. This entire statement. So this is put it in one line. They put it in one line, and here they put it so that people can understand. And this is a regular expression for IPv4. So we still do not know whether it works, because what you do is, if you want to write a program, you copy this, and then you put your own statement, your own testing. So say you pass some of your IP addresses and whether validate it, and then use it. So it's better you do not write your own regular expressions, because it can get complicated. But for understanding, you can play around with that, so you can become an expert. And these regular expressions are supported in most of the languages, and it will be almost same. For example, if you write it in shell script, it is almost similar to Python. It is like now they have generalized the regular expressions. That means /d is digit in Perl, in Python, in Java, in shell script. All of this are same thing. So regular expressions are getting standardized. So once you learn about one regular expressions, you can easily read about other regular expressions. Okay. So the reason that you require regular expressions is to extract the data from text. So just remember this. Whenever you search, you search for regex dates. Okay. So for this, you search the thing, and you can either write your own, or people might have written better regular expressions. You just look at that and try to find out what it is. So you must be able to, after doing some exercises, you must be able to read through this. What are these braces, and what is this square brackets, and all these things. So that is about regular expressions. It's a vast subject in itself, but this is about brief introduction to regular expressions. So you can just read about that in I'll send this link. This is a Python regular expressions library documentation. You can just look at this and just you don't have to remember anything. So just get familiar with that. That's all. Okay. So that's all I had. I have some assignments. So there is one more. This assignment is on exception handling. Uh, Assignment is very simple. So now you must have written already program um, for, for that previous assignment where you had JSON which is containing states, and inside those states we had active number of cases and things like that. Now you try to in that program you try to search for a state which doesn't exist. For example, let us have an imaginary state called as Chalukya. So if you enter that Chalukya, now your program will throw an error telling that I am not able to find that Chalukya. So it will stop the execution immediately and it won't execute the statements below that. So now you need to write that statement inside the try block and realize how the exception handling works. And then similarly you try to write a JSON file in read mode, and then you try to write it in some other function, and it should say that okay, this file cannot be written